Welcome to the tutorial of Thevenin and Norton Theorem. Alright, so what do I mean by Thevenin's theorem and Norton's theorem? So we have learned previously about superposition theorem. So superposition is nothing but a way for us to solve a complex circuit when it has multiple sources, right? So Thevenin and Norton's theorem allow us to analyze a complex circuit, but that's in a different way. So as you can see, when I try to represent a complex circuit, the complex circuit might have different voltage sources or different current sources. No matter what the sources are, or no matter in which combination they are, all of the sources will be represented by a voltage source, which I am writing over here as Thevenin, right? And all the resistors, they are going to be represented as Thevenin, and this is going to be the circuit combination, and this is how a complex circuit is represented in this form when I am trying to find out the Thevenin's equivalent circuit. Then kind of same goes for the Norton's equivalent circuit. So instead of the voltage and resistor in series over here, I'm going to represent all of the sources as a current source and all of the resistances as R Norton over here that you see, and those two are going to be in parallel to each other, and this parallel combination is going to be parallel to the load resistance, right? And now on to the next slide. Step one is calculate the R Thevenin and R Norton. Over here you see the equation that I wrote, that is R Thevenin is equals to R Norton. Why is that? Because the process of calculating R Thevenin is just similar as the process of calculating R Norton, right? And in order to do that, there are a couple of steps you guys have to follow. One is, if you have a voltage source, then you have to make it a short circuit. And if you have a current source, you have to replace it with an open circuit. And you have to disconnect the load and then measure the resistance across the load terminal to get the R Thevenin or R Norton. As you see, this is our the complex circuit, right? And we have to find the R Thevenin or R Norton. So in order to do that, like the instruction, I short circuited the voltage sources and I made the current sources at open circuit. There are no current sources, so I just wrote the equivalent circuit right over here. So after taking care of the sources, this is how my equivalent circuit stands. And from here we can easily say that the R1 resistor and R2 resistor, both of them are in parallel. So I just calculated the equivalent resistance across the load terminal, right? Which is my R Thevenin or R Norton. And after calculation, I found it out as 0.8 ohms. So if I want to represent it as a Thevenin equivalent circuit or a Norton equivalent circuit, then this is how my equivalent circuits would stand. So as you can see, as my R Thevenin and R Norton, both of them are equal. So this is the circuit combination for the Thevenin's equivalent circuit, and this is for the Norton's equivalent circuit. And now I'm gonna move on to which step I want to go forward. So for the Thevenin's equivalent circuit, there's a rule that is, in order to find out the voltage across the load terminal, what we have to do is we have to replace the load with open circuit and then measure the voltage across the load terminal, right? But in order to do that, after I replace the load with my open circuit, you can see the load of this terminal, so the voltage of this terminal, that's unknown. Then the current that's passing through R1, since my voltage at this terminal is unknown, so I don't know what amount of current is flowing through R1. And similarly, I also don't know what amount of current is flowing through R2. So given that these three parameters are unknown, so at the moment I'm not going to be able to solve this circuit or represent the complex circuit as a Thevenin's equivalent circuit. So what I'm gonna do is see like if I can do the same for Norton's equivalent circuit. Okay, so for Norton's equivalent circuit, the rule is I have to replace the load with a short circuit and then measure the current through that node, right? So when I replace the load with short circuit, you're gonna see that this is shorted with the ground, right? So that means the voltage of this node is 0. So when I know this is 0 and this is 28, so 28 minus 0 divided by 4, which is 7, and 7 minus 0 divided by 1, that is 7. So 7 ampere of current is flowing through R2 and 7 ampere of current is flowing through R1. Now, the current through R1 is 7 ampere, the current through R2 is 7 ampere, and both of those currents are gonna go through this node, that is this I load, that is the combination, the summation of I1 and I2. So since we figured out what's the current flowing through R1 and R2, so I'm just gonna sum them up and it's gonna stand as 14 ampere. So since the current that's passing through the load terminals, that's 14 ampere, so that stands as my Norton current, right? So if I put this value over here, so this is going to be my Norton's equivalent circuit. If you guys remember, while trying to represent the complex circuit as a Thevenin equivalent circuit, we had three parameters unknown, right? Current unknown, the voltage unknown, then the current unknown through R2 as well. So what I am going to do is answer a question that all of the students might have. That is, if I were told that I have to represent that complex circuit as a Thevenin equivalent circuit, then what step would I do? So in this case, since I could represent this entire circuit as a Norton equivalent circuit, so I'm going to use that Norton equivalent circuit to transform the equivalent circuit into a Thevenin's equivalent circuit. To convert a Norton's equivalent circuit to a Thevenin's equivalent circuit, we have to know what is our objective here. Our objective is to find the voltage across the load, which is our V Thevenin, right? So I have mentioned before that my R Thevenin and R Norton both have the same process of calculation. That means that both of them are equal, right? And for Thevenin, I have mentioned before that we have to replace a load with an open circuit and measure the voltage across the load terminal, right? Because we want to convert a Norton's equivalent circuit to a Thevenin's equivalent circuit. So now I have a Norton's equivalent circuit. You can see that I replace the load with an open circuit, right? So the current is obviously going to pass through 0.8 ohms of resistor, which is my R Norton. So that being the case, we know V is equals to IR, right? So I multiplied the I with the R and then I got the V. So this V stands as my V Thevenin. And if from here we can write the Thevenin's equivalent circuit, which is my V1 that you see, this V over here is my 11.2 volts of V Thevenin and then 0.8 ohms of R Thevenin. Then I got the R load, right? This is my Thevenin's equivalent circuit. Now I have shown you guys how to convert a Norton's equivalent circuit to a Thevenin's equivalent circuit. What if it was a vice versa? That, okay, somehow I converted my complex circuit to a Thevenin's equivalent circuit. Now how do I find a Norton's equivalent circuit from here? What if the question asks me to? So in that case, what do I have to do? I'm going to transform a Thevenin's equivalent circuit to a Norton's equivalent circuit. So I have to follow the obvious rule for that, right? Which is I have to replace the load with a short circuit and then measure the current through that node. So over here, what I did was I detached my, I replaced my load resistor with a short circuit, and then this becomes my equivalent circuit. And after that, this is my voltage, this is my resistor. So V over R stands as the current through this this path, right? And that current through that path stands as my I Norton, and that would be 11.2 over 0.8, that is equals to 14 volt. And after doing that, so in overall, my main circuit, if I want to represent it as a Thevenin's equivalent circuit, this would be the circuit. And if I want to represent it as a Norton's equivalent circuit, so this is my Norton's equivalent circuit. So easily, if you know one process, if you can find out if you can represent the main circuit as a Norton circuit or a Thevenin's equivalent circuit, then you can easily transform that circuit into the other one. So this is a very easy process to do so. Having said that, thank you very much for watching the video.